So just repeating, today's the last day of new stuff, Wednesday journals are due, Friday is test day, the review sheet is required, not optional. If your name ever appears on my board and you turn something in, please cross your name off. Oh, I didn't want that. Yikes. No, no, no. Undo. Begin. Okay, so we want to talk about linear programming. This is actually, for math, this is really new. It was invented in the 1920s, so it's less than 100 years old. So that's pretty new math for us. And it's actually a method that's truly and honestly used out in the business world. Businesses want to make a profit, and this is a great method they could use to help them analyze their production, particularly if they're like a manufacturing type company, and figure out what's the best amounts of items to manufacture so they maximize the profit. So I gave you a definition here, and the key thing is it's a procedure for finding maximum or minimum values. You're finding the highest value of something or the lowest value of something, but they're going to give you some conditions it has to meet. And that'll make more sense when I give you a problem here in a second. So we're all happily copying this down, or I can move on. So I'm going to pause. So the best way you're going to see this, you just have to see a problem. It's the only way to see what's going on is to see a problem. So you're going to need, of course, graph paper to do this, because what I'm going to give you is a function and some inequalities. The function is what you're trying to find the maximum or minimum value of, but I said given conditions. So the conditions are, in this case, x has to be a number that's 1 or bigger, y has to be a number that's 1 or bigger, and in this case they're going to tell you x plus y, the sum of the two, has to be less than or equal to 6. So I've given you 3 inequalities, 1 function. We want to maximize the function. Okay. What you have to do is you have to graph the inequalities. Don't graph the function. Never ever graph the function. First of all, it's written f of x comma y. That should be a big hint that you're not supposed to graph it. You only graph the inequality. So, how do I graph x is greater than or equal to 1? What kind of line is x equals 1? It's a vertical line. So, we will put a vertical line down 1. It's an equal sign, so it's going to be solid. For the most part, you'll find these are going to be solid. Okay, which side would you be shading if x is greater than or equal to 1? You would be shading the right-hand side. But here, with these kind of problems, this can get really messy. Don't go hog wild shading. I am just going to sort of shade along the right-hand side of this line to show that, oh, I would like to be shading somewhere to the right of this line. If you color it in like crazy, it gets hard to tell what you're doing. So that was there. The other thing I'm going to suggest, because already it's starting to be, when you put those horizontal and vertical lines on, you start thinking your origin's in a different place than it really is. Your origin, I would take some other color of ink or colored pencil or something, mark your original origin so you're sure you're counting from 0, 0. Okay, then how do I graph y is greater than or equal to 1? That's a horizontal line at 1, so we go draw a horizontal line through 1. And since it's y is greater than 1, are we shading above or below it? We will be shading above it. So I will be shading up here. So right now, where would those two regions overlap? Yeah, kind of the upper right is where we're overlapping right now. This whole area up here would actually be shaded in if we were coloring it all in. So then I've got one more line to graph, but this one actually has 2 variables. So how do I graph x plus y is less than or equal to 6? In this case, you could solve for y pretty easy, or you can t-table. This one's super duper easy too. Because you put 0 in for one variable, what's the other variable going to be? 6. I put 6 in for y, x is going to be 6. So you know you're plotting 0, 6, and 6, 0. But count these from the old origin. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Then connect the dots. And, what have we formed? We have formed a triangle. Okay, you will discover that when you do these, it has to form a polygon. You have to have an enclosed region. So it'll be, in this case, it's a triangle. It might be a quadrilateral, a four-sided figure, but it has to be an enclosed region, a polygon, in that. So I always note that it must form a polygon of some type. Depends on having inequalities as to how many sides you've got, but you have to form a polygon in the whole thing. Okay, I was going to say, Nick, do you need to go? So, you also, it's that polygon we're after. I usually take another color, kind of go around my border here, find out where exactly did all of these intersect. And so I actually have this little triangle here. Now, the interesting part of this that you have to believe me on, I said I wanted to find out what numbers make that function turn out a maximum or a minimum. We're actually going to do both. It turns out, with an actual mathematical proof, they proved that the maximum and minimum values will always happen at the vertices of the polygon. What do I mean by vertices of a polygon? Look at the corners. Yeah. So if you're going to have maximum and minimum values, it'll always occur at the vertex, the vertices on that particular polygon. So that's another thing to write. So you test the vertices for the maximum and minimum values. In our case, there's only 3 because it's a triangle. If it's a four-sided figure, you're going to have 4 vertices, etc. Is that a question?
Located at the vertex?
Yeah.
Okay.
So, what you have to do, we've actually done the hard part. We got the thing graphed. You have to go back and identify the coordinates of those vertices. So we actually have to go back into our problem and go, okay, well, there was a vertex in these 3 places. I need the coordinates. So what's the coordinates of this one in the bottom left? Yeah, that's 1 over 1 up. Okay, what about the one to the right? If you count from the origin, that's 1, 2, 3, 4, 5 over and 1 up. And then the one at the top from the original origin is 1 over and 1, 2, 3, 4, 5 up. Yeah. So the maximum and minimum value for this particular function is going to happen at one of those 3 sets of coordinates. So what you're going to do then to finally finish off your problem is you're going to take the function they gave you at the very beginning here. I'm going to recopy it a second. We have x plus 3y. You're going to take your coordinates So you're going to take the 1, 1, the 5, 1, and the 1, 5, and you are going to substitute them into this function, see which one comes out biggest and which one comes out smallest. So literally, you're going to put, this is coordinates, so you're going to put 1 in for x and 1 in for y. So I would have 1 plus 3 times 1. What's that going to give me? 1 plus 3 would be 4. So then next time I'm going to put 5 in for x and 1 in for y, which is going to give me 8. And then lastly, it says put 1 in for x and 5 in for y, which is going to be 16. So what you're looking for is you're looking for what's the highest and the lowest. So at the end, you're going to write out your final answer and say, okay, what was the maximum value we got? What was the highest value we got? We got a maximum value of 16 at what coordinate? At 1, 5. And we got a minimum value. Our lowest value that came out was 4 at the coordinates 1, 1. Okay. In the real world, when you would do a problem like this, say you were manufacturing, last class we decided we were manufacturing very elite expensive cars per day. And so they decided that X was Lamborghinis and Y was Bugattis. Somebody want some other kind of vehicle? Okay. All right. So what this is saying was, when X is greater than or equal to 1, it's saying you had to manufacture 1 or more Lamborghinis. When Y is greater than or equal to 1, you had to manufacture 1 or more Bugattis per day. But then what's this X plus Y is less than or equal to 6 doing? If this is how many you manufacture. You have the total of how many cars you manufacture. If you add them together, two types of cars, the total you can manufacture per day has to be 6 or less. Typically, the function out in the real world, typically the function is profit. How much money am I going to make? And so where I have 1x and 3y, so I'm making 3 times as much on my Bugattis in this case. So we found out that our maximum value of 16 occurred at 1, 5, so we should make 1 Lamborghini and 5 Bugattis to maximize our profit. Sometimes, though, when you do these problems, sometimes you're trying to minimize your cost, how much it costs you to make something. So if that had been this case, then we would have found out we should have, to minimize our costs, we should have made 1 of each. In this particular case, that doesn't really fit very well. But actually, they do apply this in the real world. It really helps them figure out how much should we be making. You don't want to make too many, because if you make too many, then they don't sell. You've wasted your money. But you don't want to make too few either. So this helps them figure out what's the optimum amount to make and produce in a manufacturing type situation. Cool, huh? Did we love it? You're worrying me. Okay, so that was a nice one. You're going, that was too easy. Those functions were too easy to graph. That was boring. And it was just a triangle. Triangles are boring. 3-sided figure. Not only was it a 3-sided figure, it was even a right triangle. How boring. You need more pizzazz in your lives. So, but this is a good time to stop the recording.